Hey guys, welcome back. I have another exciting one for you guys today. Proof of the product rule. This is going to be amazing. So, as always, before I do any of my proofs, which are all in my playlist, which you will see once you subscribe to my channel, you don't have to subscribe, but you could help out. Anyway, you will see that I start with something called a recall. So let's recall that the limit as h approaches 0 of f of x plus h minus f of x over h, that's the derivative, right? So I'm just going to say that's f prime of x. It doesn't have to be f, you can call it g. So the limit as h approaches 0 of g of x plus h minus g of x over h, that's called g prime of x. Great. So we're going to say, hey, let h of x equal the product of two functions, f of x times g of x, not a composition, multiply. What is h prime of x? Okay, anytime I'm doing something, I'm going to start with the definition of a derivative. So I'm going to put an x plus h everywhere I see an x, and I'm going to start there. So I'm going to say, all right, that's x plus h, right? So that's f of x plus h minus f of x, which is this guy here. I'm saying f of x plus h, but I'm typically, or I should say, I'm using h of x. Great. Now this is going to be tricky. I'm going to leave the limit as h approaches 0 out until the very end just because I'm not going to have enough room. So watch what I'm going to do here. Isn't it true that if you add something and then take something away, which is the same thing, that you didn't change any of your, expression or your equation, if you want? So let's see what I'm going to do here. I'm going to add, let's say, f of x plus h times g of x, and then I'm going to take that away, which means I never changed the problem. So I added this and I took it away, and plus something and minus something is 0. So that's what I need there, okay? So all of this is obviously divided by h. I'm going to leave that out for the next one, but let's see what we're going to do here. Great. I'm going to line stuff up together. So I'm going to use this part as one, and then I'm going to use this part as the other, okay? So let's start with the yellow highlighted part. I'm going to factor out, I know you guys see it already, I'm going to factor out a f of x plus h. I'm going to be left with g of x plus h. Excuse me, I'm going to use this and this. I need a minus, okay? Minus, so I'm going to factor out f of x plus h, and then I'm going to have a minus g of x all over h. Great. So I use that guy and that guy. Now, what I want to use is him and him. So in this case, I'm going to factor out a g of x, and I'm left with f of x plus h minus f of x, okay? And that's going to be over h as well. So I'm using the blue guy with this guy here, right? So the red and the black, and I factored out a g of x, and I'm left with f of x plus h minus f of x. And then from the black ink and the green ink, I factored out a f of x plus h. Great. Now the most important part, limits. Well, what would happen if the limit as h approaches 0? Well, that guy goes to h, so I'm left with f of x. Do you guys remember from the previous page what g of x plus h minus g of x over h? Absolutely. The derivative. Plus g of x, and now this guy here, f of x plus h minus f of x over h. Well, that's just going to be f prime of x. So what you learned is let me see if I get another page, and please pause the video and check it out yourself and take your time. I know I'm going fast, so you can just pause the video and keep track. When you have a derivative of a product, how do we know it's a product? Because there's an x and an x, okay? When you have a derivative of the product, you are going to keep the first guy, keep him, take the derivative of the second, plus keep the second guy, and then take the derivative of the first guy. And that is your proof, okay? So you're going to have to insert and take away something here. Let's do this. You're going to have to add this part and take it away and then line it up. Now you know that the derivative of a product is keep the first function, take the derivative of the second, plus keep the second, take the derivative of the first. And that's all you have to do. I hope you guys enjoyed this fun proof.